So far, we've been working with models made from simple numbers, JSON arrays, or JSON objects, and we've used a repeater to create delegates managed by a column layout as a basic view. However, Qt is much more powerful than that, offering a collection of built-in models and views that allow us to access more complex data sources and provide more advanced visualization capabilities. Let's take a look at some of these built-in models and view types as we continue to build towards our goal of creating a weather application. Most of the built-in model types are provided by the Qt QML Models module, but as long as you've already imported Qt Quick in your QML file, you won't need to explicitly import Qt QML models as well. Some of the built-in models include Instantiator, List Model, Delegate Model, Item Selection Model, and Object Model, along with utility types like Delegate Model Group and Package. The Qt.labs.FolderListModel module provides the very useful folder list model. Additionally, the Qt.labs.QML models module offers experimental QML types such as Delegate Chooser with its delegate choice and Table Model with its table model column. Finally, the Qt QML XML list model module includes the encapsulated XML list model for working with XML data. The first built-in model we're going to explore is the folder list model. You provide it with a path to a folder, and it produces a model of the files in that folder based on various filtering properties. It's a very useful model, even though it's tucked away in the Labs section of Qt. Since we have some images in our project, let's use the folder list model to list them. First, let's do a quick cleanup by removing the repeater as we're moving on to more powerful models. Inside the column layout, add a folder list model with an ID of folder list model and tell it which folder to look in. We will set the path to where the icons are located in the project. The folder list model provides several roles about the files in the folder, which are listed in the documentation. We'll use the file URL role to get the full URL of each file, and the file base name role to get its simple name, which we'll use to visualize both. Now that we have our folder list model, we need to introduce a view to show the data and create a delegate to render the roles from the data. Let's introduce the GridView. The GridView works similarly to the Qt Quick Grid or grid layout in that it arranges the delegates in a grid. It can arrange items horizontally or vertically and will wrap to the next row or column when there isn't enough space. Grid views can also scroll to reveal more delegates if they extend beyond the visible area. You can control the layout using the layout direction and flow properties. By default, GridView lays out items from left to right and starts a new row when the width is exceeded. Changing the size of the grid view will reflow the items at runtime, and the grid view will scroll if the grid exceeds the view's boundaries. Let's create a grid view. Since GridView is part of the Qt Quick module, there's no need to add a new import. Declare a grid view inside the column layout, set it to fill the entire layout, and bind its model property to the folder list model. Set the cellWidth and cellHeight to 100. GridView uses cells to manage the spacing between created delegates, which is slightly different from grid layout, but we'll see how it works visually in a moment. Now add a rectangle as the delegate, giving it an ID of delegate. Add the required properties URL, file URL, and string file base name, which correspond to the roles in folder list model. Set the rectangle's color to transparent and give it a white border. Bind the rectangle's width and height to the grid view's cellWidth and cellHeight. Now let's explain what's going on with the width and height bindings. These bindings are applied to a delegate that hasn't been created yet, but the target of the binding, GridView, already exists. The compiler doesn't know this at first, so we need to add pragma component behavior, bound at the top of the QML file to help it out. This tells the compiler that everything will be fine because the GridView does exist. Inside the rectangle, add a column layout with an ID of column layout. We'll let it adjust to its own implicit size, and then, inside the column layout, we can add an image and a label. To show the implicit size of the column layout and how it's placed relative to the GridView cell, we'll add a rectangle behind the column layout. Let's run the application. You'll see that the folder list model gives us a model of the files in the Assets Icons folder, and a delegate is created for each file, mapping the file URL and file base name roles to the image and label components. Try resizing the window, and notice how the grid view adjusts the layout based on cellWidth and cellHeight. and how the content of the delegate relates to the cell size. You can experiment by changing the cell width and cell height to smaller values and see how the cells start to overlap. You can also try anchors with the column layout to change the positioning of the content within the cell. We've created a bit of a complex delegate here to show the visual difference between the delegate size and the cell size by wrapping the image and label inside a column layout, which we've constrained to the size of one cell. Hopefully, this gives you a good understanding of how GridView works. GridView has many other features and properties to explore, so feel free to experiment with them. Now let's look at another built-in model, ListModel. FolderListModel and GridView showed us that we have some weather icons in our project. We'll use those again as we develop some building components for our weather application. But for now, let's say goodbye to the FolderListModel and GridView and reset back to a clean column layout. The list model is one of the most versatile models in your toolkit. It represents a container for us to define items within a list. List elements are defined inside ListModel using the ListElement type, which allows us to declare each item in our list with our desired roles and their values. Keep in mind that role values can't contain bindings or JavaScript expressions, only simple values like numbers or strings. Let's declare a list model with placeholder weather information for the next 7 days. Inside the column layout, declare a list model with the ID weather model. Inside the list model, we will declare a list element. This creates a model with one data item at index 0, containing 5 roles: time, weather code, temp max, temp min, and units. The time role will later be used to display the day of the week, but for now, we'll include just the date. The temp max and temp min roles represent the daily temperature, and units will specify whether we're using Celsius or Fahrenheit. The weather code is tied to the weather icons we added earlier. These codes match specific weather conditions, with 0 representing sunny, 1 for cloudy, and 95 for thunderstorms, for example. These weather codes can be found on the Open Media website, which is linked at the end of the course. Let's go ahead and add 5 more days of sample weather data, leaving the 7th day to demonstrate how to add data imperatively. You can see the similarities to a JSON array of objects, but ListModel offers useful APIs that are hard to achieve with a simple JSON array. To add the missing 7th day, use the ListModel's append function, which accepts a JSON object containing the keys as roles and the values we want to append. When the list model is created, our last item will be appended. ListModel also includes other functions such as set, insert, remove, and move for modifying data. The get function can retrieve data from a specific row. Now let's introduce a list view and a more complex delegate to display our weather data. List view is ideal for our list model since it arranges items in a horizontal or vertical list. Like GridView, it can scroll if the list exceeds the visible area. Inside the column layout, let's create a list view. Set the orientation to list view horizontal so that our 7-day weather forecast is displayed horizontally, and let's bind the model to weather model and set the delegate. Here we will use the list view's attached object to access the view's width, ensuring each delegate fills the list view. This binding requires pragma component behavior, bound. Now, add the required properties from the weather model. Next, let's add a label, an image, and 2 more labels inside the column layout. First, a label for the day, then an image for the weather icon. Lastly, we can add 2 labels for min and max temperature. For some visual enhancement, ListView provides transitions that can be triggered when items are added, removed, or moved. Let's bind a transition to the add event, so when the extra day's data is added, the transition will run. Now, when you build and run the application, you should see the 7-day weather forecast displayed across the lower part of the window, and the last day delegate will fade in 500 milliseconds later than the others. Before we wrap up with ListView, it's worth mentioning that ListView and many other views offer various attached properties. We've already used ListView.view, but there are others, such as ListView.isCurrentItem, and signals like ListView.add and ListView.remove. Feel free to explore the additional features and experiment with dynamically adding and removing delegates by modifying the models in various ways. We've built a static weather forecast. Now let's make it live by integrating real location search and weather data from OpenMedio.